So you have two types of lymphoid cells. You have, B cells and T cells, the lymphocytes, and you have what people call innate lymphoid cells. And so innate lymphoid cells are reacting on the spot, while T cells and B cells, lymphocytes, need more time. So the importance of these innate lymphoid cells is reacting right away on a perturbation of the tissue. Let's say you are infected by a bacteria, and so within minutes, the tissue is going to say, hey, we're infected, and they're going to activate these innate lymphoid cells, and right away they're going to induce an immune response against this bacteria. But then it takes several days for the T cells or the B cells to be generated. But what they have, the innate lymphoid cells don't, is memory. So the second time you see the same bacteria on the skin or elsewhere, the innate lymphoid cells probably don't remember, but the T cells will, or the B cells. A lot. You want more? A lot, because I come from the Institut Pasteur, and the Institut Pasteur has been founded by Louis Pasteur, who showed that microbes are vectors of disease. And so that's probably the dominant view, even now, we have from microbes, that they're vectors of disease. At the end of the 19th century, someone called Elie Metchnikoff was recruited to the Institut Pasteur, and he proposed that bacteria can also be vectors of benefits. And he showed actually the existence of, he showed the potential impact of probiotics, and that they may have a good effect on health because they combat the bad bacteria. So we had to wait for basically 1 century to be able to study good bacteria, what you call symbionts, for example, in the gut, and understand what they do, not infecting us, but also help us to digest, to protect us, to regulate our intestine, that it doesn't go into cancer. So that's now what we see. We see that bacteria, for example, can be part of us, of our system, and work with us for their benefits because they can live, and for us because we can digest much better and be protected. We discover more and more things, also because the technology is now able to answer these questions. We know since a lot of time that, for example, if you put cocaine on a cell, that the cell is going to react to it, a T cell, a B cell, or lymphocyte. But to study how the brain or the nervous system interacts in the mouse or in the human, interacts with lymphocytes, is now something we can now understand. But what it looks like is that they both have a role in recognition of what happens in the environment. If for example, you're hungry, then the nervous system tells to put your energy in searching for food, and therefore all the energy may be not used to fight an infection. So that's the way now, in the general way, to see that it has to be regulated. Or for example, you are in the jungle and you're infected by a virus. The energy of the body, the brain tells you, puts the energy in fighting the virus. It puts that in the immune system. But now comes a lion, and so you have the choice. You're going to be cured from the virus, or you have to escape because a lion attacks you. The brain tells you, run. So you run. All the energy you put for fighting infection goes into running. And that may be dangerous for you because you may die from infection. But that's kind of the regulation, obvious regulation of the immune responses by the brain.